Black holes are among the most fascinating, mysterious, and mind-bending phenomena in the universe. For years, they've captivated scientists, astronomers, and even movie directors. But what do we really know about them? In this video, we're diving deep into the ultimate truth about black holes, revealing what's behind the most shocking, mind-blowing discoveries and the unanswered questions that continue to perplex us. From their birth to their death, from the event horizon to the singularity, we'll explore everything that makes black holes the ultimate cosmic enigma. What happens when you get too close to a black hole? Can time actually slow down near one? What lies beyond the event horizon? And how do black holes shape the very fabric of space and time? These are just some of the questions we'll answer in this journey through the mysteries of black holes. We'll also discuss the latest breakthroughs in black hole research and how scientists are pushing the boundaries of our understanding. So, if you've ever wondered about the truth behind the black holes that exist in the far reaches of space and how they might affect everything around them, including us, this video is for you. Join us as we explore one of the most mind-bending topics in modern science, uncovering secrets that might just change the way you look at the universe forever. So, what exactly is a black hole? At its core, a black hole is a region in space where the gravitational pull is so strong that nothing, not even light, can escape from it. To understand this, we need to break down the fundamental concept of gravity and how it interacts with matter. Black holes form when a massive star runs out of fuel and collapses under its own gravity. This collapse causes the star to shrink, becoming infinitely small and dense, creating what we call a singularity. But don't worry, we'll get to what that means in a moment. Surrounding this singularity is a boundary known as the event horizon. This is the point of no return. Once something crosses this line, it's trapped. Even light, traveling at the fastest speed in the universe, can't escape. The idea that light can be sucked in and disappear forever is what gives black holes their mysterious reputation, S. But here's where it gets even more mind-boggling. The size of a black hole doesn't necessarily have to correlate with its mass. A supermassive black hole at the center of galaxies can be millions or even billions of times heavier than our Sun, yet its event horizon may only span a few million kilometers across. In fact, some black holes are so massive that their gravity warps space and time itself, creating what we call space-time curvature. This phenomenon is one of the cornerstones of Einstein's theory of general relativity. And if you thought that sounded crazy, wait until we dive deeper into the bizarre physics that govern black holes. Black holes are invisible, right? After all, nothing, not even light, can escape them. So how in the universe do we even know they exist? Well, while we can't see black holes directly, we can detect them by observing their effects on nearby objects and space itself. You see, black holes interact with their surroundings in ways that reveal their presence, even if we can't see them. One of the most common ways scientists detect black holes is by looking at the behavior of nearby stars or gas clouds. When a star is too close to a black hole, it gets pulled in by the black hole's gravity. This causes the star to move in an unusual orbit. And by tracking that movement, astronomers can infer the presence of a black hole. But it doesn't stop there. As matter falls into a black hole, it heats up and emits X-rays. These X-rays can be detected by space telescopes like NASA's Chandra X-ray Observatory, allowing us to see the shadow of a black hole as it devours matter. This is one of the key ways we detect black holes in space. In 2019, we achieved something that had been the stuff of science fiction for decades. We captured the first ever image of a black hole. Using a network of radio telescopes around the world, scientists combined data to produce an image of the event horizon of the supermassive black hole in the center of the galaxy M87. This image was a groundbreaking moment in the history of astrophysics. That image, though fuzzy, was the first direct evidence we had of the existence of black holes, and it solidified the theories we'd had for over a century. But what about black holes that are far away or in the centers of distant galaxies? With advancements in technology, scientists are constantly developing new ways to observe the effects of black holes and push the boundaries of what we know. Now that we know how black holes are detected, let's explore what happens when matter crosses the event horizon and enters the black hole. Now, let's dive into one of the most mind-bending aspects of black holes. What happens when something crosses the event horizon? Remember, the event horizon is the point of no return. Once anything, be it a star, a planet, or even light itself, crosses this boundary, there's no coming back. But what exactly happens when matter falls into a black hole? As matter approaches a black hole, the gravitational pull becomes stronger and stronger. This warps space-time around it, what we call space-time curvature. The closer you get, the more stretched and distorted the fabric of space and time becomes. And this is where things get truly wild. As matter nears the event horizon, it experiences what's known as spaghettification. This means the gravitational forces are so intense that they stretch the object out into a long, thin shape, like spaghetti, before it's torn apart. Imagine being that object. The gravitational pull on your feet would be so much stronger than the pull on your head that your body would get elongated like a piece of spaghetti. This stretching happens because the gravity is much stronger at the closer end to the black hole. Once the object crosses the event horizon, it disappears from view. From the perspective of an outside observer, it seems to freeze in time, as the light from it is unable to escape. But for the object itself, it continues falling toward the singularity, the point of infinite density at the center of the black hole. At the singularity, space and time as we understand them break down. The laws of physics, especially general relativity, can no longer describe what happens at this point. It's a place where matter is compressed to infinite density, and the very concept of time becomes meaningless. So, what's on the other side? We don't know. What happens beyond the event horizon is one of the greatest mysteries in astrophysics. Do black holes lead to other universes, or are they just a one-way journey to destruction? The truth remains elusive, but that's part of what makes them so fascinating. Now that we've covered what happens when matter crosses into a black hole, let's explore the idea of black holes leading to other dimensions and the wild theories surrounding these cosmic giants. Black holes have long fascinated scientists and the public alike with their mysteries and strange properties. But one of the most intriguing ideas surrounding black holes is the possibility that they might not be the end, but rather gateways to other universes or dimensions. This theory has sparked the imagination of physicists and science fiction writers alike. To understand this, we need to dive into some of the most mind-bending concepts in modern physics. The idea stems from something called the multiverse theory. This theory suggests that our universe might not be the only one that exists. Instead, there could be many different universes, each with its own set of physical laws and properties. One of the most exciting possibilities is the idea that black holes could act as portals, connecting our universe to other universes within the multiverse. The idea is that when matter falls into a black hole, it could travel through a tunnel or wormhole and emerge in a different universe on the other side. This concept is heavily influenced by the study of general relativity and quantum mechanics, two of the cornerstones of modern physics. But how likely is this? Well, the short answer is that we don't know. Wormholes, hypothetical tunnels through space-time, are predicted by the equations of general relativity, but no one has ever observed one in nature. Some scientists believe that black holes could, in theory, form wormholes that connect to other universes, while others argue that these wormholes would be unstable and collapse before anything could travel through them. Another intriguing idea is that the singularity at the center of a black hole could be a gateway to another dimension. Some theories suggest that the singularity might not be a point of infinite density, as we currently understand it, but could instead be a bridge to another part of space-time, potentially leading to an entirely new universe. One of the most famous proponents of these ideas was the late physicist Kip Thorne, who explored the concept of wormholes in his book, The Science of Interstellar, and in his work on the film Interstellar. According to Thorne, if wormholes do exist, black holes could be the key to discovering them. However, it's important to note that these are just theories, and we have no direct evidence to support the idea that black holes can lead to other universes. While these ideas are exciting and fascinating, they remain firmly in the realm of speculation. Despite this, the possibility of black holes being connected to other universes opens up new avenues for research and exploration. If we could one day find a way to observe the behavior of black holes in greater detail, we might uncover clues that point to the existence of parallel universes or other dimensions. Until then, the mystery of what lies beyond a black hole remains one of the most captivating questions in all of science. One of the most captivating ideas associated with black holes is the possibility that they could be used for time travel. Time travel has long been a popular subject in science fiction, but could it actually be possible in the real world? Could black holes, with their mind-bending gravitational effects, hold the key to unlocking the mysteries of time travel? The idea that black holes might be connected to time travel comes from the concept of space-time, the four-dimensional fabric that combines space and time into a single entity. According to Einstein's theory of general relativity, massive objects like black holes warp space-time around them, creating intense gravitational fields that can have strange effects on the passage of time. One of the key ideas here is something called time dilation. Time dilation occurs when an object experiences a strong gravitational field or is moving at speeds close to the speed of light. The stronger the gravitational field, the slower time passes for that object, relative to someone far away from the black hole. This is a result of the warping of space-time caused by the black hole's gravity. In theory, if you were to approach a black hole, time for you would pass much more slowly than for someone who stayed far away. From the perspective of the person observing you from a distance, you would appear to freeze in time as you approach the event horizon. But from your perspective, time would continue normally. This effect, known as gravitational time dilation, has been confirmed by experiments with satellites and clocks in orbit around Earth, which experience slightly different passage of time due to Earth's gravity. But could black holes be used as a form of time travel? Some scientists believe that it's possible, in theory, that the extreme warping of space-time around a black hole could allow for time travel to the future. If you were to fall into a black hole, you might experience a form of time travel, where you move forward in time at an accelerated rate. However, this would only work if you were able to survive the intense gravitational forces as you approached the event horizon, a nearly impossible feat for any known material. The real mind-bending idea comes from the concept of closed time-like curves, CTCs, which are theoretical paths through space-time that loop back on themselves, essentially allowing for time travel to the past. Some solutions to Einstein's equations of general relativity suggest that black holes could, under certain conditions, create these closed time-like curves, potentially enabling travel back in time. But there's a catch. These solutions are highly theoretical, and no one has ever observed a closed time-like curve in nature. One of the most famous solutions involving time travel is the concept of a wormhole. Wormholes are hypothetical tunnels through space-time that could connect distant points in space and time. Some theories suggest that black holes could be linked to wormholes, and if you could travel through such a wormhole, you might be able to travel through time as well. But, like closed time-like curves, wormholes are purely theoretical at this point, and there's no empirical evidence to support their existence. Despite the fascinating possibilities, it's important to remember that time travel through black holes remains speculative. There are many challenges to overcome before we can even consider the idea seriously. For one, the extreme conditions near a black hole, such as the immense gravitational forces and radiation, would make it impossible for anything to survive the journey, let alone a human being. Theoretical physicists continue to study black holes and the nature of space-time, but we are still far from figuring out how, or even if, time travel could ever be possible. As we wrap up our journey through the fascinating world of black holes, It's important to look ahead and explore what the future holds for black hole research. In recent years, we've made incredible strides in understanding these mysterious cosmic objects, but there's still so much more to discover. The question remains, what's next in the study of black holes, and how will future breakthroughs shape our understanding of the universe? One of the most exciting areas of research is the ongoing study of black hole mergers. Thanks to the groundbreaking detection of gravitational waves by observatories like LIGO, Laser Interferometer Gravitational Wave Observatory, we now have the ability to observe the ripples in space-time caused by the collision of black holes. These mergers provide a wealth of information about the properties of black holes, such as their mass, spin, and the nature of the event horizons. As gravitational wave detectors improve, we can expect to learn more about these phenomena and even observe mergers between black holes that are located billions of light years away. Another major frontier in black hole research is the study of the event horizon. The event horizon is the boundary around a black hole beyond which nothing, not even light, can escape. This makes studying it incredibly challenging, but it's also where some of the most fascinating discoveries are likely to occur. In 2019, the Event Horizon Telescope (EHT) collaboration made history by capturing the first ever image of a black hole's event horizon in the galaxy M87. This milestone opened up new possibilities for observing the behavior of black holes in greater detail. In the future, astronomers hope to improve upon this achievement by capturing even more detailed images of black holes and their surroundings. The next generation of telescopes, such as the James Webb Space Telescope and the upcoming Extremely Large Telescope, ELT, could provide unprecedented views of black holes and their accretion disks, allowing scientists to study them in ways that were previously impossible. One of the most tantalizing questions in black hole research is the nature of the singularity, the point at the center of a black hole where gravity becomes infinite and space-time breaks down. We currently don't have a complete theory of what happens inside a black hole, but some physicists believe that understanding the singularity could lead to a major breakthrough in our understanding of quantum mechanics and gravity. The pursuit of a theory of quantum gravity, an attempt to reconcile general relativity and quantum mechanics, is one of the biggest challenges in modern physics. Black holes could play a crucial role in this quest. Another exciting possibility for the future of black hole research is the exploration of their role in the evolution of galaxies. We know that supermassive black holes sit at the centers of most large galaxies, including our own Milky Way. Some scientists believe that black holes play a key role in regulating the growth and formation of galaxies. By studying how black holes interact with their host galaxies, we can gain insights into the processes that shape the universe on the largest scales. Finally, there's the possibility that new theories about black holes will emerge, challenging our current understanding and leading to a deeper, more profound view of the cosmos. For example, theories like the holographic principle suggest that the information contained within a black hole could be encoded on its event horizon, offering new ways of thinking about the relationship between gravity, quantum mechanics, and information. These kinds of theories could revolutionize our understanding of black holes and their role in the universe. In conclusion, the future of black hole research is incredibly exciting. With new technologies, better observational tools, and groundbreaking theories, we are on the verge of uncovering even more of the mysteries of these strange, powerful objects. As we continue to explore black holes, we may unlock new dimensions of space, time, and even the very nature of reality itself. Now let's explore some truly mind-boggling facts about black holes that will make you see the universe in a whole new way. Black holes can evaporate. Yes, you heard that right. Black holes don't last forever. Over incredibly long timescales, black holes lose mass through a process called Hawking radiation. This results in them slowly shrinking, and eventually they can vanish completely. However, this process takes longer than the current age of the universe, so don't worry about black holes disappearing anytime soon. 2. Falling into a black hole isn't instantaneous. While it's true that nothing can escape from a black hole, Once it crosses the event horizon, you won't be immediately crushed or pulled in. If you were to fall into a supermassive black hole, you would cross the event horizon intact. But as you go deeper, you would eventually experience spaghettification, a stretching of your body due to the difference in gravitational pull from head to toe, eventually ripping you apart. The largest black hole is astronomically huge. The largest known black hole, called TON 618, is a supermassive black hole in a distant quasar. It's around 66 billion times the mass of our Sun. To put that into perspective, the entire solar system could fit into the event horizon of such a massive black hole with room to spare. It's nearly incomprehensible. Chanam. Black holes sing when they merge. When two black holes collide, they don't just crash in silence. The collision generates gravitational waves, which are ripples in space-time that can be detected on Earth. These waves can be converted into sound waves, producing a ringing noise akin to a bell. In fact, the first black hole merger detected in 2015 produced such waves that scientists have compared them to the sound of a chirp. 5. Black holes grow by feeding on stars. Black holes can feed on the gas and dust around them, as well as entire stars that wander too close. As they consume material, they grow larger, forming an accretion disk, a swirling mass of hot gas that emits intense radiation. This process causes black holes to continue growing in size and mass over time. Time stops at the event horizon. As you approach the event horizon of a black hole, time slows down significantly due to the intense gravitational pull. From an outside observer's perspective, it would seem like time stops entirely for you once you cross the event horizon. However, from your point of view, time would continue normally as you fall inward. Black hole mergers are more common than you think. Black hole mergers happen frequently in the universe. Every time two black holes collide, they produce powerful gravitational waves, which can be detected by advanced observatories like LIGO. These mergers give us a glimpse into the violent dynamics of the universe. There's a black hole at the center of our galaxy. Our own galaxy, the Milky Way, harbors a supermassive black hole at its center called Sagittarius A. This black hole has a mass roughly 4 million times that of the Sun and has been a key object of study for astronomers looking to understand how galaxies and their central black holes interact. The event horizon can change size. The size of a black hole's event horizon depends on its mass. As a black hole absorbs more material, its mass increases, which in turn causes the event horizon to expand. This means the boundary between the known and unknown in a black hole is constantly shifting, depending on the black hole's growth. 10. There are more black holes than we can detect. Scientists believe that there are many more black holes scattered throughout the universe than we are currently able to detect. Most of these would be smaller black holes, which are harder to spot. As technology improves, we'll be able to find more of these hidden giants lurking in the cosmos. Looking ahead, black hole research is only going to get more exciting as technology and our understanding of the universe continue to evolve. Here are some thrilling prospects for the future. Imaging the event horizon in greater detail. We've already captured the first ever image of a black hole's event horizon in 2019, thanks to the Event Horizon Telescope, EHT. But this is just the beginning. As telescopes improve, especially with next-gen projects like the EHT's Expanded Array, we'll be able to capture even sharper images and study the innermost regions of black holes with unprecedented clarity. Understanding the mysteries of Hawking radiation. One of the biggest challenges in black hole physics is understanding Hawking radiation, how black holes can lose mass and evaporate. If scientists can better observe and measure this phenomenon, it could completely change our understanding of the universe. Theoretically, this could even lead to breakthroughs in quantum gravity and the unification of physics. Discovering new types of black holes. Right now, we know of stellar mass black holes, supermassive black holes, and a few intermediate mass black holes. But there could be many more types that we haven't discovered yet. For example, there are theories suggesting the existence of primordial black holes, which may have formed right after the Big Bang and could offer critical insight into the early universe. Merging black holes and gravitational wave astronomy. Black hole mergers produce gravitational waves, ripples in space-time, that were first detected in 2015. As detection methods improve, we'll be able to track even more mergers, providing detailed information about black holes' behavior, mass, spin, and how they interact with one another. This will open up new ways to study the very fabric of space-time itself. Exploring the firewall paradox. One of the biggest mysteries in black hole physics is the firewall paradox. It suggests that at the event horizon, the fabric of space-time may be violently altered, creating a wall of energy that would destroy anything that passes through. If this is true, it could challenge our fundamental understanding of quantum mechanics and general relativity. Solving this paradox would unlock entirely new realms of physics. Exploring the role of black holes in galaxy formation. Supermassive black holes are thought to play a crucial role in the formation and evolution of galaxies. Understanding their influence could give us a deeper insight into the processes that shape galaxies over billions of years. Are black holes the key to understanding the structure of the universe itself? The search for life. Near black holes, could black holes actually harbour life in some strange way? While it seems implausible, some scientists have speculated that there could be exotic forms of life in the intense environments near black holes. These theories, though speculative, push the boundaries of what we consider possible in the search for life beyond Earth. Black holes remain one of the most fascinating and mysterious phenomena in the universe. From their incredible power to bend space-time to their potential role in the creation of galaxies, these cosmic giants continue to challenge our understanding of physics. Whether it's the mind-bending effects of spaghettification or the possibility of black holes being gateways to other dimensions, there is still so much to discover. As our technology improves and our knowledge expands, we're on the brink of uncovering even more about these enigmatic objects. Whether you're a casual observer or a passionate scientist, the mysteries of black holes will continue to captivate and inspire. So, keep your curiosity alive, because in the realm of black holes, the truth is often stranger and more amazing than fiction. If you enjoyed this deep dive into the secrets of black holes, make sure to like, subscribe, and hit the bell for more cosmic content. The universe is full of wonders, and we're just getting started.